Now, yes, there's like COVID, there's dysentery, there's like disease everywhere. If you take a microscope and look down at the dirt or like maybe your shoes, you'll see like disease and pathogens everywhere. Well, if disease is everywhere, I've got a question. How exactly do we all not die of disease at some point? Because there's like disease everywhere. Well, not just your skin. What's your skin part of? Not just your body. I mean like a system. The immune system. Now, I can say that I'm an expert at this. I mean, when I was like 6 years old, I wrote a 5-page long essay about it. So yeah, I think I'm an expert about it. True story. But still, a lot of people hear about the immune system and they're like, oh, it's just these one cells that come and kill the viruses and nah. Well, that's not what the immune system is. Why would it be called an immune system if it was just one thing? Then it would probably be like immune cell. So this is a extremely simplified way of looking at the immune system. The reason why you don't die every single minute. Now, first of all, you need to see that the immune system has two main ways of dealing with an approaching enemy, which could be a bacteria, a parasitic worm, or, of course, COVID-19 viruses. But anyways, in order to start out, we must talk about what they do whenever, like there's something coming in. Immediate response without knowing what it is. And this would have to start right here with this. Not your hand, but your skin. Your skin is the main barrier against pathogens when it comes to your body. Another one could be your snot. And of course, if it ends up getting into your body, then the acid inside of your stomach is gonna kill it. But what if, cut your fingers off and boom! Now there's a gaping hole for the pathogens to come in. How exactly are we gonna survive this? Okay, well, we're not going to the actual part where we recognize what this is and are like, okay, time to go kill this smallpox virus. No, not here yet. But before that, we need to visit a few cells that carry things known as machine guns and lightsabers, I guess, whatever floats your boat. But anyways, now these cells come into the scene and start spraying a bunch of hormones all over the place, which then alerts even more cells, for example, neutrophils and other stuff and all that stuff, Fun fact, neutrophils, they are extremely deadly. They carry machine guns, and whenever they run out of ammunition, they just blow themselves up. Wow! We have suicide bombers in our bloodstreams. But now, if the virus comes in, then all these cells will pile up together and do something known as take the virus in and beat it up from the inside. And yes, that's what they actually do. The cells, being basically like jelly goo and all that stuff, can literally just change its shape, swallow up the virus, the bacteria, whatever it is, and immediately break it down into tiny atoms. Well, it doesn't actually do that because that would cause nuclear fusion, and I don't like when my entire arm blows up because there's a battle going on in there. So yeah. But some other things include, for example, remember the neutrophils. When they blow themselves up, they basically are like, goodbye cruel world, and immediately break parts of their skin until they die and ooze out all its DNA membranes, which is also extremely toxic. Not to us, because then that would be pretty bad, but to the viruses. Fun fact, whenever you scratch the bumps that come right after it starts to heal your wound, and then you scratch it, and well, that's pus. And pus are dead bodies of neutrophils. So yeah, when you look at a bead of pus, remember that these are the dead bodies of your protectors, so you should salute them. Just kidding, just throw it away because it's disgusting. Plus, they're dead. So yeah. But anyways, now what happens if the viruses are still beating up your immune system real hard like that? Well, another and our final part of your immune system that is oh god, there's a virus here, so let's kill them. I don't know what it is though, but I don't care, let's kill them. Then this one is an information cell. It basically creates information. What it does is it flies around, finds one of the viruses, rips it into pieces, covers its entire body with the dead bodies and stuff of the person that who it just killed, and then flows into the bloodstream and goes look for helper T cells. And when they find the helper T cells, well, a big clump of them, they will be like, "Hi, excuse me, does this thing, is this familiar to you?" Because literally in every single part of your body, there are helper T cells. And every single helper T cell in your body knows how to deal with every single virus ever. Even man-made viruses, the helper T cells will have at least a single cell that can deal with that. And that's just awesome. I mean, you've got weapons for every single disease ever in your body. Imagine what we can find out about that. About, let's say, COVID, or a disease that makes mushrooms grow on your back, or I don't know, makes your hand look like a tree. Wait, that's a thing? That's a thing? Okay. Good thing I don't have that. Good thing nobody else has that except for those 4 other people who have it in the entire world. But anyways, they go to the helper T cells and rub their disgusting dead bodies of the virus onto them. And most of the helper T cells will be like, "Get away, I don't know what that is." But soon, usually after a week, what will happen is the helper T cell that actually recognizes that gets touched by it and is like, "I know how to deal with this virus!" And immediately picks it up and starts duplicating itself. When it duplicates itself enough, then what happens is it immediately waddles down over to the helper B cells, or the B cells for short. You know, for example, you can basically call the B cells weapons factories. Because have you heard of the words antibodies? Well, this is where antibodies come in. Woohoo! Now, the helper T cells go down to the B cells and start rubbing their stuff all over them. But just remember, this is only one half of the group. The other half is going somewhere else. I don't know, say battlefields. And that's what's going on. But anyways, now these helper B cells immediately immediately duplicate themselves into millions of copies. And then they start chucking up the antibodies and spitting them out. Just like for the T cells, there's only at least 1 or 2 B cells that actually know how to deal with this virus that would be infecting you right now. So, yeah, you know what happens. All the antibodies come out. What is an antibody, Andrew? Okay, here's what an antibody is. Now, you know what a protein is? Oh, you mean like those things in the nutrition facts? No. I mean like the stuff that makes up every single thing that can move and live. All those stuff besides atoms. So yeah, antibodies are literally just proteins. They are usually V-shaped and they can clip straight on to whatever the virus is if it's the right one. But anyways, now they spread it all out and the antibodies flow forever and ever and ever until they reach the battlefield, where then they slowly as ever push into the enemy lines, connect with them, and immediately cause the enemy to blow up. Because that's kind of what they do, right? Well, not all of them can do that. Like, they mainly are like, here, I caught them. Here, come eat them. But some of them can literally just blow them up, you know, because that's what the immune system wants to do. Blow stuff up. That's what everybody wants to do. Blow up, blow up, blow up. Okay, I'm getting off course. But what about that other group of helper T cells? Well, before the antibodies arrived, they rushed down to the battlefields. Now, the stomachs of all these fighting cells are humongous. But still, when they get too full, they start to die out. And the helper T cell is like, no, there's still a war to go on. Keep on fighting now. And the soldiers immediately go, yes, sir, and continue fighting. Except with an extra pinch, teaspoon, tablespoon, a gallon of anger, and immediately just chuck themselves into the enemy lines and rips the diseases apart. Not eating them yet, but literally just ripping them apart, stashing them into his pockets, and continuing to rip them. And also all those stuff is an extra treat for later, because, you know, food. But now, here the battle turns. Well, most of the time the battle turns. If the virus comes into the lungs, then. But usually the battle turns against the disease. Take that, Ebola, or COVID, or smallpox, or the flu, or chickenpox, or cowpox, or whatever disease is infecting you right now, dysentery. Yeah, there are lots of diseases. Tree hand syndrome. But anyways, now what happens here is the diseases immediately start retreating. And when the diseases retreat, they also basically mow down themselves too. Meanwhile, all of the neutrophils and the soldiers and all the helper cells and the antibodies follow them until most of them would escape, but the few stragglers would simply cluck them up and die, because, you know, war. And now, here, some new cells come down to the wound and bind it so that more diseases cannot come in. And soon, it will start to grow, and boom, that scar on your finger is no more, behold. And that is the most simple way of talking about the immune system. The way that we don't die of literally anything on Earth.